What up, guys? Today, we're going to be disproving gravity, as you can see here. Okay, so gravity should be pulling this egg down in water, right? Oh, look, it pulls it down. Puts it in this water, right? Wait, it floats. Because I add a little salt to it, it can't possibly counteract the effects of gravity. The egg floats because of buoyancy, right? Well, let's go take a look at the equation for buoyancy. FB equals PGV. Okay, what does that all mean? FB is the buoyant force in newtons. Makes sense. P is the density of the fluid. G is the gravitational acceleration. What? That can't be right. We just disproved gravity. And V is volume in displaced fluid. What's that? Is that the gravitational acceleration? Wait a second. Buoyant force never pushes down. So then what's pushing down? Of course, it's gravity, obviously. The buoyant force only pushes an egg up if it can overcome the effects of gravity. Right? And these forces on the sides right here cancel out because they're pushing in the same directions with the same amount of force. So the net buoyant force is always going to be pushing up, never down. Let's take another look at this. Some people say that in order for gravity to be a thing, the buoyant force must be pushing down more, like it must displace more fluid than its weight due to the acceleration of gravity. But its weight is the acceleration of gravity. It should not displace more. It just does not make sense. Here are the four fundamental forces that are the four fundamental forces. The first one's gravity, the second one's weak nuclear, the third one's electromagnetic, and the strong one is, well, strong nuclear. Yes. And they're from weakest to strongest. Gravity is by far the weakest of all these forces, and it requires an incredible amount of mass for you to even start noticing an effect. While strong nuclear is this type of stuff that holds the atoms together. Here on Earth, gravity is 9.8 meters a second squared, right? So for 1 kilogram of weight, 9.8 newtons of force are applied to it towards the ground. Correct? Okay, now what we're going to do is we're going to calculate a buoyant force of this using the 9.8 newtons per kilogram, which is caused by gravity, obviously. So what we're going to start to do is we're going to weigh this egg. I'm not going to weigh the other one because it's just going to go in the normal water, which is distilled, by the way. So it's just water. It's 63 grams. Since the egg weighed 63 grams, which is 6.3% of 9.8, you can get 0.063 times 9.8, because, 1 kilogram is 9.8 newtons of force, and then it gets translated into, after you do the math, you get 0.6174 newtons of force pushing down. So the buoyant force has to overcome 0.6174 newtons, which is a very little amount of force. Now we change the Newton force into a force that you can more understandably see and comprehend, be pounds force. 0.138 pounds of force is pushing down. That is not much at all. So buoyancy has to counteract that force for the egg to float. Now what we're going to do is we're going to calculate the density of that egg so that we can match or greater densify, if you can call it that, the water with salt so that it will float. So now we have a beaker here with 200 milliliters of water. And now if I add the egg to it, it should displace just above 50 milliliters. So let's just say that's 60. Okay, since our egg weighed 63 grams and it displaced 0.06 liters or 60 milliliters, then we get a density of roughly about 1.05, and the average density of an egg is 1.03, so it's a little more dense than the average egg. And the density of water is 0.9 0.982, which is very close to 1, so we'll just call it 1. Okay, now we need to figure out how much salt we need to add to the water to increase the density enough so that the egg will float. So since we have 200 milliliters of water here, and since it's practically 1, I zeroed out the glass, it's 200 grams, as it's practically 1 gram per cubic centimeter. So now I did some, and then you get 200 grams, and adding salt to water, very little increases the volume, so I'm just going to keep it the same right there. We got 200 grams of water, and then we're going to add 20 grams of salt. And that's going to raise the density to 1.1, and what we need for our other sticky note here, we need it to be above 1.05, and the starting density of water is 1. So if we add 20 grams of salt, we should increase it, so it's 0.1. Okay, so here I weighed out 20 grams of salt that I'm going to add to the 200 milliliters of water to increase the density, and I did zero out the paper towel as well. Now I added the salt in there, and as you can see, it hardly raised the volume at all. And once it dissolves, it should go back directly down to the 200 milliliter mark. I went ahead and added 50 more milliliters, and I also weighed out 5 more grams, so it's proportional still. And it should still be an increased volume of 10%. I just thought it'd be easier to show that the egg will float. So now we're going to add the egg into the water, and then I got my buoyant force equation out here already, because the density of the water is 1.1 now, as we measured before, and the gravitational constant is 9.8, and then we're going to measure the volume of the displaced fluid now. Now we're going to put the egg in the water and get the displaced volume. Jeez. And as you can see, it is above the 50, so let's just round that to 60, because it's above the 50. Focus. Yeah, it's above the 50, so we're going to call that 60. 60 milliliters. So as you can see, the displaced fluid is above 50, so we're just going to put that as 60 right there, and as you can see, the egg is floating in the solution we made. So then we calculate it out in our equation right here. We get 1.1 as the density we calculated earlier, 9.8 is the gravitational constant, and then we get 0.06 liters because it displaced 60 milliliters, and that's how you do that. And then you get 0.6471 newtons of force. Now, that is greater than what we calculated how much force that it would require for the egg to float. So it would require 0.6174 newtons of force. That's how much gravity is pushing down on it. And the buoyant force is greater than that of gravity, so therefore it floats. Yes, so gravity is, in fact, real, and you can't have buoyancy without gravity, because gravity causes buoyancy. Thanks for watching.